All right. So for our 2.5 today, we're going to start working at factoring stuff, and we're going to start factoring pretty much trinomials here of the form. Now, guys, understand this. Is there any letter out in front of x squared here in our title? No. So we assume that this is just 1x squared right up there. All right. So you may want to jot that in there. I'm not telling you how to, but it says, how can you use algebra tiles to factor the trinomial x squared plus bx plus c into a product of two binomials? I'll show you some algebra tiles here, but I don't think we're really going to have to use those too much. I think that all the expanding of binomials that you've done should help you understand how to work backwards from that to get back to factored form. So we want to know, how do we use those tiles to factor x squared plus bx plus c into the product of two binomials? All right? It's not terribly difficult to do. Our job today is factor some quadratics of the form x squared, or trinomials if you will, of the form x squared plus bx plus c, and then we're going to factor to solve some real life problems. Okay? So quick vocab. There's nothing up here that you haven't seen yet this chapter. You know what a polynomial is. It's a sum of binomials. It's a sum of binomials. So an example would be like 3x squared plus 7x. Okay? What kind of family does that belong to right there? What polynomial family does that belong to? Binomials. So again, if I ask questions, what degree is that? You would tell me it's degree 2. And if I said, what's the leading coefficient within that? You would say it's 3. Okay? We all recall FOIL method, right? F stands for do the first. O stands for what? Do the outside. I stands for multiply your insides. And then L stands for do the. Okay, and then zero product. If I have two numbers, A times B, if a number A times a number B, and this was our last section, equals 0. What's that mean about A or B? One of them has to be 0, right? So this should all be a review for you right there. Okay? So let's get to the heart of the matter, because we're going to be factoring, and it's just going to be of the form just 1x squared. We're always going to have a 1x squared in this section. Now when we start moving on, there's going to be different values like 6x squared out front. And I'll show you how to handle that. But guys, our job is this: factoring x squared plus bx plus c when b and c are what type of values? Positive. Okay? Here's what you're really looking for when you do this. You're trying to think of two numbers that add up to your b value and times to your c value. Okay? So what's the b value in this expression that we're trying to factor backwards, kids? What's the b value in this? 9. And what's the c value? So we have to think of two numbers that we need to have, two numbers that add to 9 and times to what? Now, you guys are smart kids. I know you have those numbers. What are those numbers? What two numbers, when added, make 9, and at the same time, when multiplied, make 14? 7 and 2. What is 7 plus 2, kids? What's 7 times 2? 14. Okay, so all you do when you factor this is we're going to write a set of parentheses. Your factored form becomes the following. It's going to be a set of parentheses. You put your x's out front. Doesn't this x and x make the original x squared right here? Okay, you said positive 2 and positive 7, right? So you come in here and write plus 2 and plus 7. Okay, look at your inside and outside. Your inside, 2 times x is what? And then your outside is 7x. Wouldn't that combine to this 9x part up here? Okay, what's 2 times 7 make for the last? 14. Okay, you guys see if you can think of this one. I'm going to try and really trick you. I'm going to go x squared plus 15x plus 36. Okay, see if you can't factor that. So you're going to put your x's here and your x's here. So you're looking for two numbers that add up to what, kids? 15, and at the same time they're going to times 2, 36. See if you can think of them, all right? Anybody think of the two numbers yet? Think you got them, Blake?
Yeah, 3 and 12.
3 and 12. Let's check 3 and 12. Blake, what's 3 plus 12?
15.
Does that check out for that middle term, kids?
Yep.
What's 3 times 12, kids? So I would write that part as x. And the order doesn't matter on this, okay? So we're going to write this as x. We're going to write this as x. What did you say your values were again, Blake?
3 and 12.
3 and 12. So I would write plus 3 right here. Now, here's the deal. Did anybody have trouble coming up with 3 and 12 right away? It's kind of tough for people sometimes. So here's what I'm going to tell you to do today, kids. This is pretty slick. Okay, you guys know the website here, Mr. Parsons Math. You may want to get into this today. I'm not going to tell you, but I'm going to show you this right here. All right? This is going to be helpful for you, and you're going to want to use it in case you can't think of some terms. But kids, do you see where it says online resources and calculators right here, down towards the bottom? Click on that. And then the calculator, maybe write this on your notes. It says sum and product calculator. You see that link right there? So we're going to use this thing a little bit today. We're going to use this to save us some time. But sum and product calculator is the one we're going to kind of use to help us with this right here. And this is where it takes you right here. All right? So what I want you to understand is this. When we're factoring the form x squared plus bx plus c, the number on the end right here, this 36, is always the product. This is going to be the product. 15 is going to be the sum. So what I can do in this little calculator is pretty sweet. What value am I going to type in for the product? 36. Now I know that's hard to see up there on the board, but if you type in 36 up here, what sum did I want to type in, kids? And then you just hit submit on this. Kids, what values do they give you right here? 3 and 12. So as Blake suggested earlier, the values you're going to need right there are going to be a positive 3 and a positive 12. So we factor that as x plus 3 times x plus 12. All right. Well, this is pretty nifty because I'm going to tell you why. You're going to love this thing. I promise it. Yes?
It's blocked.
Oh, my God. Are you kidding me? Well, I'll get it unblocked today. How's that sound? All right. We'll use the one I have up there, and I'll get that unblocked today, okay? You happy with that? And in fact, orange is kind of my favorite color. All right. Maybe I'll try and embed it today. Maybe I can do that. All right, let's try some more. Now, guys, let's look at example 2. This time, instead of factoring x squared plus bx plus c, what do you notice about your middle term right here? This is a negative and this is a positive. Now, guys, anytime you have an order that goes negative, positive like this, you will always, always, always try to think of two numbers that multiply to positive 27, but add to a negative 12 this time. Now, I want you to understand something. Kids do this a lot. They're like, I can't think of two numbers that add to a negative but multiply to a positive. If that's ever the case like this, your two numbers would actually have to be a negative number. Right? So can you think of two negative numbers that multiply to positive 27, yet they add up to negative 12? Anybody think of those? Yeah. So negative 9 and negative 3 would work, wouldn't they, kids? Just help me out here. What's negative 9 plus negative 3, kids? Negative 12. What's a negative 9 times a negative 3? positive 27. So if I was factoring, this would factor into, and the order doesn't matter, x minus 9 times x minus 3. Okay? So I just want to show you about factoring the next one. I want to make this a little bit more difficult. Okay? So suppose I have, I don't know, x squared minus 27x plus 180. Now, is it getting harder to think of all the factors of 180? And then the two factors that multiply to positive 180, they need to add up to what here? Negative 27. Now, this is where that calculator will come in handy, and I'll try and get that unblocked for you here this morning. But I'm going to go in here, and I'm going to say, all right, what's the product need to be in the example I just wrote down, kids? So I put positive 180, and what do I have to put in for this next one, though? You want negative 27. Then I'm going to hit submit. I don't know, your eyes might be better than mine. Can you read these values up here? Negative 15 and negative 12. So to factor this, kids, this would factor into what times what? What would you put in this first set of parentheses? X minus 15. What's going in the next one? X minus 12 is your simple factored form. Again, two values that add up to the middle term and at the same time multiply to that C term. All right? Questions on the first page right now? Go like this if you're feeling pretty good about it. All right. Any questions so far right now? Well, let's rock the second page with these notes. And these notes are really long, guys. These notes are really, really long. These notes. All right, never mind. That's not funny. I'll stop. What are we trying to add up to, kids?
7.
But what are we multiplying to this time? The only way I can multiply to a negative number using two factors is one number is a negative and the other must be a positive. Okay, this kind of tells you that if I'm multiplying to a negative number here, do I need more positives than negatives or more negatives than positives? Okay, can you think of two numbers that times to negative 8 but add up to positive 7? Blake, if you've got it already.
8 and negative 1.
8 and negative 1. What is 8 times negative 1? That's the negative 8 product part. How about the 8 plus negative 1?
7.
So Blake, if I was asking you to factor this for me, you would write this as x minus 1 times
X plus 8.
How about we do this then? What if I have x squared minus 5x minus 36 here? Raise your hand if you think you know this. Trying to find two numbers that add to what value, kids? Negative 5. But at the same time, you have to multiply what? Negative 36. And you and I both know that if I'm going to multiply to a negative, one number must be positive and the other must be negative. Now this is kind of a giveaway here, kids. Am I going to have more positives than I am negatives or more negatives than I am positive? Try to have more negative values than you do positive. Blake, you're hot today. Go for it.
4 and negative 9.
How about 4 and negative 9? What's 4 times negative 9, kids? Negative 36. What's negative 9 plus 4? Negative 5. So Blake, read those numbers again to me, please.
4,
You say x minus 9?
X plus 4.
Awesome. And again, if you're having a hard time thinking of them, I'll get you a resource, but unlike the Minnesota Vikings offensive line, it is blocked. Yeah, my team stinks. I get it. I'm a realist. Want to be an optimist, but I'm a realist. What did we have to multiply to in that one again?
36.
And add up to? Kids, what are the values again? we write this as x minus 9 times x plus what? 4. Okay? So let's put some of this into action, kids. How does this work? How do we make this work? Take a minute and read this example right here, okay? Okay. Says a gardener plants a rectangular lettuce patch. That rectangular patch that he was talking about is right in here, kids. Right here. Okay, and they tell you the area of that garden is what? 120 square feet. So in this yellow area right here, there's 120 square feet right there. Ooh, that's not showing up very well. Let me try this. 120 square feet in there, right? Okay, so kids, it says, what is the area of the whole garden? Well, guys, the whole garden is a square. What's the length of this garden up here? What variable do they use? S by what? S. Now, would you guys agree then, if we can figure out what S is, we can find the area of the garden? All right, so let's talk about this right here. Let's deal with that area that's, first of all, 120 feet here. Kids, if this whole length from top to bottom is S, and this is 5 feet, what would the distance from here to here make? Wouldn't it be the total distance S minus how much? S minus what here? 5. So this distance right here is going to be, and I don't know why they use S in mathematics because it looks too much like a 5. So I'll do my best to differentiate it. But do you guys agree that the length of that yellow or that lettuce garden there is S minus 5 feet? Because the whole length would be how long here from top to bottom at what I'm pointing at? S feet. And how much are we subtracting out, kids? So that makes this S minus 5. So what's this going to be? If this whole length is S and this is 12 feet, what's this going to be written as down here for lid? S, not plus 12, but it's that total length S, and we're taking out 12 from that side. Okay. Now, guys, here's what I want you to write. Do you agree that the S minus 5 times the S minus 12, or the length times the width here, would have to multiply to what area here in this lettuce garden? So I'm going to write this down over here. So by our dimensions over here, we know that S minus 5 times S minus 12 must equal what total area? 120. Okay. Let's do some expanding or foiling, if you will. Guys, this problem kind of is a culmination of everything we've done in this chapter. So let's go ahead and foil the right. What's S times S going to get you, kids? S to the second power. All right, let's do our inside and outside. Our inside, that would be a minus 5S, wouldn't it, kids? How about the outside? What would that be? Negative 12S, right? So what's a negative 5S and a negative 12S going to combine to? So I'm going to write minus 17S. Okay, kids. How about that negative 5 times negative 12 on the end? What's that going to be? Positive 60. But this is still equal to what value, kids? All right. So what we've done, kids, is this. We've modeled an expression with an area that's written as S minus 5 times S minus 12. We know that equals 120. We went ahead and foiled the left side and said, hey, this becomes the expression S squared minus 17S plus 60. Now, if you think back to the last section, we were able to solve our equations when factored form was equal to what value? 0, right? Does what I have on the left here equal 0 on the right, kids? But could I manipulate where I'm at to make this equal 0? What could I do to both sides to make something equal 0? Let's make this 120 a 0. How would you get rid of positive 120 here, kids? All right, help me with my north of Highway 3 math skills. On the left, you would have s squared minus 17s. What's positive 60 minus 120 going to get you? Negative 60. And that would equal 0. Oh my gosh, you guys. We have an equation like we had from last section. We said, if I could just factor this stuff and have two parts equal to 0, it's easy to solve. But don't we know how to factor this stuff on the left now, kids? What are we trying to find two numbers to add up to? Negative 17, but at the same time multiply to what? Negative 60. Again, if you're multiplying to a negative, that value must be positive. One's got to be positive, the other has to be negative. So let me jump in here. You guys have the equation. This little calculator, you're going to love it. What are we trying to multiply to, kids? Negative 60. How about negative 17? Submit. Guys, what are our values there? What are our values?
Negative 23.
So to factor this left side over here, we would have s minus 20 and s plus 3 equals 0. Right? Perfect. Because what we've established here is everything that we did in the last section. All of a sudden I have an equation that's like, oh, how many parts are equal to 0? Or how many parts could be equal to 0, kids? 2. This means that s minus 20 could equal 0? Or what else, kids? Now let's talk here, kids. What would s equal in this first part? So I'm going to say, so s equals 20, or s would equal what? All right, so we've got those two values established. Now, kids, go back to the question. What's the question in this real-life example really asking you? The area of the whole garden. In other words, a whole length of s times a whole width of s. Kids, my s values, what are possible s values here again?
20 and
Now, think about this. If we're talking about dimensions in the real world, would it ever make sense that, hey, I planted a garden, it's negative 3 feet by negative 3 feet. Would that make any sense? So why even want to use this? It could, but I don't think that you're going to grow very much. All right? What's the length of the garden going to be in real life terms here?
20 feet.
Yep, this is going to be 20 feet up here. This is going to be 20 feet this way. I don't even want that negative 3. So my area of the garden, kids, is going to equal what times what? 20 times 20, which is? Anybody? 400 square feet. Okay. That, my friends, is what we're doing. Give me a show of hands. How many are feeling good about this factoring of the form x squared plus bx plus c? We've got to find two numbers that add to b and at the same time multiply to c. If you can do that, you're going to be golden. All right? You said you would like me a lot better if I could get